Dear friends, welcome to our aerodynamics class, and today's class will be the introductory class for aerodynamics. And today we are going to study about only the fundamentals, and tomorrow we are going to take from the potential flow. So that is what I can say, that is the introduction to aerodynamics. First we will try to understand, before going into the aerodynamics, a big topic, we should understand what is the meaning of dimension and unit. A dimension means what we mean. A dimension is a measure of a physical variables without any numbers. For example, if we measure the room of the length something we measure, length is a dimension. Length is not the unit. 1, 2, 3, it is a numbers. So they are the having number units. So in the same tape, if we look it, or maybe a same measuring tape or a same measuring scale, we will take it. Somebody will say this room length is 10, means there is a unit is required. 10 is, what is that? 10 meter or 10 feet. So that meter and feet are the units. So that is the way I can say a unit is the way to assign a number. When we are assigning a number to the unit, that means feet is the unit, 10 feet. They were assigning a number, or to the measurements, to dimension. To any dimensions, when we measure a number, then we can call it the unit. For example, same one, the length. Length is a dimension. Length is not the unit. Length can be measured in feet. Length can be measured in meter. Length can be measured in light year. That means it is a distance. So that is the way we can say. So let us look about some more this one. It is a continuation of that aerodynamics, and these are the most fundamental things. And if we will not do this one, and tomorrow's class or in the future classes, it will be little bit difficult. So let us look about that. What is the meaning of force? We know it. Force is nothing but our mass into acceleration. And if we will do it, what we will try to measure, what is the dimension and units of it? So we will try to do the dimension of force. That means if we express the force, what is the meaning of force? Force is nothing but the mass. Mass is, we can write as a m. Then force is nothing but our mass into acceleration. If we look, we will try to put it mass in the form of, we write mass is m. And acceleration is the velocity by time. Velocity is the how much distance we cover in a particular time. So that means we can take this one is our velocity and this is the time. So that means this one I can replace with this. So with that, simply I can write L, m is m, L and T divided by T is the by T square. So that is the way I can say this is the dimension. L, m, T to the power minus 2 is my dimension. But in case I want to write in SI systems, so in SI systems, in that unit, if I write, what I can do, I can say m I'll write separately, L I'll write separately, and T for the time I'll write separately. So as a result, what I'll get the unit? M I'll write kg meter per second square. This is the way. So my unit is the basically what we can say, my unit will be, this is my unit, and my dimension is, this is my dimension. This is the way we can do it. So let us see about that. When we talk about something SI units, only what is the meaning of SI units? Only SI unit is there, or some other units? That also we should little bit spend time on that, and we should do for it. Let us see. So in that case, SI units means, what is the meaning of SI units? There are different units are there. Like somebody, we measure in meter, somebody measures in feet, somebody measures in yard, somebody miles, somebody light year. So what are the different systems are available to us? But from the aerodynamics point of view, not only that, little we will extend of it and we will see. But in our talk today and in future, we will be talking only the SI units. SI units means it is the system international. That means internationally it is accepted. That is the units. That one, what we can do for L, we will take meter, mass, we can take kilogram, and time, we will take second, and currents, we will take ampere, and Kelvin for temperature, and any molecular weights means mole, and candela. That is the way we will measure the SI unit systems. And FPS system, that is foot pound second, FPS systems. That MKS system. Okay, let me talk about this little bit. FPS systems. That if we talk about our FPS system, where they use? In America, they use foot, they use mile and pound and second. But everywhere you go, whether SI system, MKS system, or maybe the FPS system, time nobody is changing. Time is second only. Okay. MKS system, that is meter, kilogram, and second. So then you will talk about the CGS systems. CGS is centimeter, gram, and second. EMU system, that is for the electronic people they will use, and electrical people, and this is for also the electronics, electrostatics people they will use. So let us see, we will concentrate for us, we will do only from here the SI units only. Other things we will not do it. In case anywhere, we will find the another one for our computations or maybe for our understanding, we have to convert it to the SI units. So let us talk about that. So when we talk about this, you see, what are the different dimensions and the units? Are units or dimensions are available in SI units. In SI units, if you will say length, length is for the L. Length for L, M, mass for M, time for T, and temperature, also temperature for T, or maybe we can say theta. Theta is nothing but the degree. We can say it is the degree Celsius. So we measure either in the degree centigrade or in Kelvin. Kelvin we do, it is the absolute temperature we will take, that is from the absolute zero we measure. So with that, area is equal to how much? Anywhere area we know, if you will take a rectangle or maybe a square, A into A, the A square, L A into B. In case we will take, for example, if we will take a rectangle, in case this is my A and this is my B, AB, that means length and length. Length and length, what is the length? Is M. So L into L, this is a length, this is also a length, this is another length. So length into length will give me my L square, will give me the area of some certain area. So we know it, how we measure the area. Similarly, volume, speed. Speed is nothing but meter per second. That means how much distance or how much length I am going in a per time. That means per second. So we can go say that one, meter per second. So all these things, what are the parameters we are going to use in this aerodynamics, I have described, and in this table it may be useful for you so in future. So, and this is an important table. This table I will be referring again and again. To going for this, we have to understand some relevant properties of the aerodynamics, which property will be helpful for us. Without this, it will be difficult. So that's why I want to give some properties of this one, of our materials. So what we will do? We know it. There are some forms of matters. How many forms we know? Because anywhere we study about, it is a solid, liquid and gas, right? Solid, liquid and gas. These are the three are very commonly used. But this is okay for us up to when we travel up to the supersonic speed. So that means these three, that means the above three forms are corresponding to that factor is decreasing the rigidity of the bond of the molecules of which the matter is composed. That means solid, it is molecules are more rigidly fixed, liquid it is little bit loose, and gas it is they are moving freely. This is the way the three forms we basically we use it. So these are the three forms. Okay, but apart from that, when we go for the hypersonic speed, in hypersonic speed, it is not only the Mach number is not the only difference. Mach number that time, what the properties of the material or the surrounding air will change. So that will come as a, all the molecules, they will be not in the molecule form, they will dissociate and it will be in the ionic form. In the ionic form, when we will do it, so what is that one that we call it? We call that is a plasma stage. That means when there is a re-entry vehicle comes, or you have recently you would have seen it, how the Perseverance have landed, that you have seen the how the shock waves has formed. So with that simulated photo what you have seen it, that means all the molecules will dissociate and they will become ions. And with that, what is the meaning of the plasma? That plasma state, let us see about that plasma state. A plasma state is a special form of gas in which the atoms are ionized. That means in the these top three, happily it will follow the our all the laws. In this mainly the gas, it will follow our the all the gas law, Boyle's law, Charles law, Dalton's law, everything it will follow. But when it will come to the plasma state, we cannot apply the isentropic rule here. So for that's why our hypersonic speed will also be a matter. That's why I wanted to highlight this one. This matter is also a important. Okay, so we'll come when we'll come study the hypersonic. That time we'll talk about that how we are going to solve and what is that difficulty you will have. Not only this, in the recent past we have got a one more form also of matter, that is called our the Bose-Einstein condensate. What is this one? Probably, yeah, most of you know it. We known as a most popularly known as a back form. Okay, back form. What does it mean? Back form is back is a state of matter. Also, it is called the fifth state of matter. Earlier, we are knowing the only three and plasma is the fourth. But most recently, we have introduced the fifth state of the matter, which is typically formed when a gas is bosons at low density. When in the upper atmosphere density is low, temperature is low, and density is cool to a temperature very close to the absolute zero. What is the meaning of absolute zero? Absolute zero means it will come the minus 273 Kelvin, minus 273.15 Kelvin. In that case, why it is important for us? It is very, very important from the aerodynamics point of view. So though it is practical applications, it has not come, because how the communications will happen, so media will happen, how the wave travels in between it. So that is important. So for that purpose, I have added today the Bose-Einstein condensate. So this is also I have added. So if anybody asks you people how many forms are there, you never stop with the either three or the fourth one. Recently we have added the Bose-Einstein condensate. So let us look into the some more properties of, mainly we will today concentrate with the gases. With the gases we will concentrate, and let us see what we will do it. We will do the some properties of gas. So when we will talk about the some properties, what are the properties you will look mainly in aerodynamics? We talk about the pressure, density, temperature. Mainly we concentrate with this. Not all the things anywhere you will go into it. You first will say, what is this one, your pressure? P by P naught, T by T naught, rho by rho naught, density. That means pressure, density and temperature are important. So what is the meaning of a pressure? Pressure is nothing but our intensity of this molecular bombardment force on a static pressure. So that we call that is a static pressure. So all the molecular bombardment will be there on a particular surface. Then we can call. So then what will be its dimension and what will be its unit in SI units. So that also we see it. So the pressure is a force per unit area. So what is its? We can measure the pressure. Pressure is a force per unit area. Force per unit area. And it has the dimensions. That means, what is the force? Force is nothing but our Newton or kgf. And area is our L square. That's what we know it, right? So that means per area. So what will be its unit? That is a force per area. So that means ml to the power minus 2, that is our force divided by area, L square. So if we will resolve it, we will get ml, this one. And if we will same way, m we can write as a mass is kg, L for the meter square, and T is the times per meter per second square. This is the way we can write. So that means that is the way we write our is the dimension, not the unit. Temperature. At any time we measure the temperature. What is the meaning of the temperature? I have told you, and of course more detail we will talk about, and temperatures of different, how the kinetic energy and other things are going to change. That we'll talk in some time back. I have told in my thermodynamics class, but we will talk in future. So what is the temperature? How we measure? Temperature we measure in either degree centigrade or Kelvin. That means, but for our purpose in aerodynamics, we'll use only the Kelvin, absolute temperature. So what we will do? Temperature is its dimension is, we write the theta or degree, and its unit is, that is the degree centigrade. How much this one is there, that we can see it, and is Kelvin. Kelvin is the absolute temperature. So this is the way. That means when we measure the absolute temperature, that means we measure from the absolute zero. From the absolute zero we measure. So let us talk about some other property. Density. When density is there, the density of a material, what is the meaning of it? That means how much material is there, contains in a given volume. That means how much is the amount of materials in a given volume. In this we can able to do it, right, with this given volume. So what does it mean? That means if mathematically we will express density, or no, there is a small mistake here. Small mistake, my dear. This should be the, we write not P, this should be the rho. It denotes as a rho. When the limit tends to 0, how much material it will be have, mathematically we express like this. Okay. So please make a corrections there. It is not P, it is a rho. Okay. And again the same way, what is the volume? We have come back. Volume dimension is L to the power minus, volume is the L to the power 3, and mass is in kg. Mass is in kg, dm by dv. If you will do it, that means kg per m cube. Correct? Kg per m cube will be the unit, and m L to the power 3 will be the dimension. So most of the time the student get confused between the dimension and units. That's why I want to revive this one. Okay. So next class onwards we will do our potential flow. So anyhow, let me continue with this today's thing. So in case if somebody is curious from the curiosity point of view, you will take the, have you heard about the STP, standard temperature and pressure, at mean sea level? At mean sea level, you will ask, sir, what is the density? We know the pressure, but what is the density? In that case, what is the standard temperature? That is the 15 degrees centigrade. 15 degrees centigrade is equal to plus 273 if we will add it, 288 Kelvin, absolute temperature. And what will be the pressure at that time? Pressure will be 101,325 Newton per meter square. This is the pressure. And what will be the density? 1.2256 kg per mq will be the density. If somebody will ask, these are the values we have to remember, and we have no need of asking that data, what is called the data table for it. Okay. So let's talk something about our next property. Without, I felt this, without these properties, if we will talk, then it will be of no use. So that's why I am coming. What is the viscosity? Most of the things, anywhere we talk about the inviscid flow, but in reality it is viscous. So in real world, to understand, we talk about the viscosity. So viscosity, what is the meaning of viscosity? Viscosity is the gradient as the tendency of the fluid to resist sliding between the layers, or more rigorously, a rate of change of shear strain. So this viscosity, we can divide into two parts. So one part is we can write our kinematic viscosity, and one is the kinematic viscosity. Obviously another one will be the dynamic viscosity. So that next one is our dynamic viscosity. So how we can define the dynamic viscosity? So let us see the dynamic viscosity, or more appropriately we can call this is the coefficient of dynamic, or absolute absolute viscosity. So with this we can measure the viscosity of the fluid. So let us come back to our some more. It's how we denote it. We denote this one is in the form of a mu. Probably this mu will be utilizing again and again when we will study about the Reynolds number. So with this, dynamic viscosity is denoted by mu, and this mu will be utilized. Without this, boundary layer or any real fluid analysis will be difficult. So for this equation, how we write it? Mathematically, we write it is equal to F by A is equal to mu into V by H. So this is a fundamental one from the definitions we have derived. And then what will be its dimension? F is the force, A is the meter, A is the meter square. So we can write, or mu is equal to, if we will take F into H, A into V, and if we will solve it, we will get it is M per M means kg per meter per second. Kg per meter per second, correct? In case we look it, this is kg per meter per second. So with this, we can measure the dynamic viscosity. But you can see it, a unit of mu, or therefore we can measure kg per meter per second. Okay. And let us see about the kinematic viscosity. What is that kinematic viscosity? The kinematic viscosity, we will say, this is the definition, or most frequently we will use than the mu, and we call this one, we denote as a nu. So this nu, this is the way, that definition, that how the F, V and H and F are there, that is the way the definitions are here. So with this, when we will get nu is equal to nu by rho by density. That is, nu is nothing but the density also comes to the picture. Now, if you will dimension all the dimensions, you will put the mu and the rho, we will get, what we will get it? We will get the dimension L square per meter. yes, per second. So that is meter square per second will be its dimension. So this is the way we can write the properties. Okay. So with this, some more property I thought of that, not leaving it today's class. So the specific heats, most probably, most frequently, you will use any aerodynamics you will study, CP, CV, gamma, all these things, that specific heat, ratio of specific heats, its usage are too much. And with this, there all our derivations are depending. So what is the specific heat means? The specific heat of a material is the amount of heat necessary to rise the temperature of a unit mass of material by 1 degree. You see the definition. So in thermodynamics you would have studied the same thing is the definition, and same thing we are going to utilize in our aerodynamics too. So what is this? How we can heat can be raised? Heat can be raised either at the constant volume or maybe at the constant pressure. The constant volume, when we will raise the temperature, we will call it the CV, and when we will do at constant pressure, we call it the CP. So let us see first the CV. CV will be the when a dry air is at normal aerodynamic temperature, when we will do it to raise 1 degree or 1 degree centigrade or 1 Kelvin from the standard one for a pure air. If we will raise, how much energy is required? 218 joule per kg per Kelvin. That is for CV value. Same way, if you look the CP value, so CP value is 110 by 1005 joule per kg per Kelvin. If there is most frequently you people use one parameter called gamma, that is the ratio of specific heat. So that is very important. So that why it has come, that we will discuss probably in some coming classes. So see what is the CP by CV, the ratio of specific heats. If we look it, this is the most important from the high speed flow. That means when flow will become the compressible, so we have to do it. So that is denoted by gamma. Gamma is nothing but your CP by CV, and that is equal to is 1.4. If actually not 1.4, it is 1.403. So if you will do it, or maybe there is some approximation will be there, that you can look it. Okay. So let us look about. So thank you very much for attending today's class or viewing it. So we'll hope that tomorrow next class onwards we'll do the potential flow. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.